Hello everyone, welcome to this session of AI, and today we're going to be looking at how we can use artificial intelligence to solve problems around us. And in particular, I have picked out fake product detection, or we're going to be looking at how we can use AI to detect whether a product is fake or original. So when we dig deep into that, many times people tend to spend a lot of money, or you spend money buying a product and you're thinking it's actually original or it's what you want. And yet people or the sellers out there are selling counterfeits at the same price as the original product. So we want to see how can we differentiate between an original product and a counterfeit with the use of AI, so that people can be able to get value for their money. All you need to do is just scan this product and you'll be able to see whether it's original or fake or and we are going to do that through the help of AI. So what are we going to need, or what will we need when doing this, or how are we going to apply AI in solving the problem? We're going to use image processing. We're going to use computer vision, things like cameras and scanners to observe the products and look for those features that show that a product is original. So when we're trying to establish a data set, we're going to look for those products, those particular features that we can compare with. If we have a test product that we can use and compare the test product with our data set to see if the product is actually original or a counterfeit. Then we can also use text processing, and that we'll be looking for features like the logos and the brand names. So if we can set up a data set whereby we've established how an original logo looks like or how an original brand name looks like, and then you come with your test product and it's not matching or adding up, then we can be able to establish that that product is fake. So the type of data that we will need, or we're going to use, visual data that is made up of images or the videos that are captured by cameras, the things that the camera can be able to see, for example, the colors, the quality. I mean, if we can get as far as that, then the texture, things that are visible. Or if we take an example of shoes, you can look at which features are there on the shoe. Is the logo right? Is the brand name right? Those things that you can, the data that you can capture by just taking, or by just taking a picture of the product. And then we will also need text data, that is to scan. For example, you can scan the logo or scan the text, the brand name, and you can see what you can pick from that data. Then we look at the differences between supervised and unsupervised learning. So what I can say about supervised learning is an agent, or should I say an AI model? An agent is like an AI model. It observes input and output, an input-output pair. You give, when you're training this AI model, you give it an input and its corresponding output, so that it can be able to establish that if I have this input, the output is this. So at the end of the day, you're training it that if you get such an input, the output is this. So it generates, or it learns the function that maps this input to the output. So at the end of the day, if you have been training it, showing it that if you see a four-legged image of something that's an animal, at the end of the day, if it sees a four-legged image, it will be able to know that that's an animal. Then when we go to the unsupervised learning bit, The agent observes the input and it creates the patterns on its own. Remember, before we were looking at a scenario where the input and output are both there, so it's just going to know how to map the two. It's just going to learn that, okay, this when this is this, the output is this. It has both. But then for unsupervised learning, there's no output for the AI model to actually base on to conclude. So it's just going to look at all the sets of inputs provided, and it's going to draw its own patterns and maybe try to cluster the similar data together. So it will look at, for example, now if you give it four-legged animals now, it will be like, oh, okay, these are four-legged animals. If I see that, I'm trying to see that these are okay. So if I see four-legged creatures, these are animals. So it will be like, okay, let's cluster them. Then again, it goes ahead to cluster. If I see four-legged creatures with horns, those are cows, or yeah. So it goes ahead to draw its own conclusions or to draw its own patterns. It learns its own patterns, and then it goes ahead to cluster the data into groups. So when we look at some of the supervised learning techniques, we have classification, like I said before. The test product is brought before the model and it's tested, or the model observes this test product and it's able to see, okay, which category does this product fall under? So it classifies it according to the features that it has already. And it's like, okay, I know already that if something is like this, it should be like this. So it classifies it that, okay, if it's this, if it's a four-legged creature, then it's an animal. Then we can also use regression. And then for regression, we have a certain, we have the output. Remember, this is supervised learning. So the AI model knows what kind of output is going to come out of this. So it's basically, we have the output already. Should I say like a given set of responses or output? And it's going to look at this input that you've given it, or the test product, and it will be like, okay, out of all the things that I have as responses, which one will do best? Which one is the best response that I can get? For example, now if I'm to give an example, if you have four-legged, if you give it a four-legged creature, and it's trying to see, okay, now I have a four-legged creature, then it goes into the output and it's like, okay, this is actually an animal. So yeah, it's more like estimating a response. It has already the sets of output that it can give, but it's estimating what best response can be associated with the test data that have been given. Then for unsupervised learning, we have clustering. The model looks at the test product as scanned and then clustered into different groups, maybe according to their similarities or their differences. Yeah. Then the technical challenges I'm likely to face. Training the model to attain a level of accuracy can be difficult because you know how these things are actually artificial. So you want it to be able to actually attain that level of accuracy where it can be like, you know, this is original and then this is fake. Now that can be difficult because we are literally just training it. It can never be 100% accurate. So that may be a technical challenge. And then errors can come about due to failure of the model to learn the algorithm correctly. For example, you know how these things are just programmed, so something can fail, errors can come up, and maybe it tries to learn the functions or make its own patterns to learn the patterns, and then maybe it learns them wrong, or you end up seeing that it has actually scanned something and it has brought it out as original and yet it's fake, or vice versa. So all these challenges can come along. Yeah, those are some of the things some of the challenges I hope I may face while doing this project. then the possible solutions could be training or actually learning, since for my case, learning these, learning the necessary, should I say, programs, or the necessary learning those things that I actually need to train and design the AI models so that they can be accurate. Then when we come to accuracy, recall, precision, and F1 score, these are like how you can grade, or not grade, but it's like there are measures of how our predictions can come out. If you're looking at, okay, the AI model has now scanned something, so has it scanned it correctly? Has it scanned a fake product as an original, or an original as an actual original, or an original as a fake? So when we're looking at all these things, we can group them under accuracy, recall, precision, and F1 score. So accuracy is the number of correct predictions out of the total number of predictions. And if you're to use other words, it would be the fraction of the predictions that the model got right. So you have, it does a number of predictions, yeah? And then you look out for that number that it got right. Like, okay, maybe some will fail, but then those that it actually got right. Then when you go to precision, precision is a measure of how many positive predictions, of how many of the positive predictions made are correct. Because you can be, a prediction can be made and it's actually positive, but not necessarily correct. It can be in line of what you want, but is it actually correct? So the measure of how many of these positive predictions are actually correct, that's what we call precision. And then recall is the measure of how many relevant predictions were made, because as we train these models, they're of course going to make some decisions or some predictions, and you're just like, okay, this is really wrong, this is not relevant at all. So how many of these, the predictions that it has made, how many of these were actually relevant? Like how many of these can we based on to actually draw a conclusion, this is original and this is fake? So those relevant ones are what we call, the measure of those relevant is recall. And then F1 score is the harmonic mean of precision and recall. That's like, there's a whole formula, which we'll see, I think, as we go on in this series, the AI series. And yeah, lastly, we have AI evaluation matrix. So under these, we have classification accuracy, and I picked out 2, and logarithmic loss. So classification accuracy is the ratio of the number of correct predictions to the total number of input samples. For example, we have our test products. It tests them. You carry out you sample quite a number of products, and you detect whether it's fake or not. And then out of all these that you've carried out of the whole sample, which ones are actually correct? The number of correct ones. So if you have a high ratio, that means your model is actually correct. Your model is actually good, because then it's more accurate. Like you've carried out tests on on a moderate sample, and many of them have actually come out correct. So that means your model is valid, or you can evaluate that, okay, now my model is, yeah, it's a valid one. Then for logarithmic loss, this works by penalizing the model for any false classifications or predictions.